The gut microbiome isn't just along for the ride, it's driving the car, tuning the radio, and occasionally rewriting the owner's manual. Among its many talents, one of the most underappreciated is its role in modulating vitamin B metabolism, especially niacin, B3, and folate, B9. These vitamins aren't simply absorbed from food or supplements. They're also synthesized, transformed, and regulated by the microbial ecosystem that lives in your gut. And the effects ripple far beyond digestion, shaping inflammation, energy production, and even mental health in surprisingly powerful ways. Let's start with niacin. While most dietary niacin comes from protein-rich foods or fortified products, your gut flora can actually produce niacin de novo from tryptophan, a metabolic pathway that exists in some species of gut bacteria. This means your microbiota can serve as an internal vitamin factory, supplementing your intake depending on who's living in your colon. But the real intrigue lies in how microbial composition influences niacin bioavailability and NAD metabolism downstream. Certain bacteria not only generate niacin but also participate in the NAD salvage pathways, tweaking how much of this crucial coenzyme is available to human cells. Since NAD is central to mitochondrial function, oxidative stress management, and DNA repair, the microbial impact on niacin metabolism could influence everything from cellular aging to metabolic disease risk. But here's where it gets interesting. When the microbiome is out of balance, what scientists call dysbiosis, niacin pathways can get disrupted. Studies have shown that in inflammatory states, microbial niacin synthesis can decrease, or worse, be shunted toward generating toxic byproducts like 2-PY and 4-PY, which accumulate in kidney disease and other chronic conditions. This raises an important question. Is your microbiome helping you age gracefully, or is it quietly sabotaging your B3 metabolism behind the scenes? Folate metabolism may be even more tightly woven into the gut ecosystem. Many species of bifidobacteria and lactobacilli are able to synthesize folate, particularly in the colon, where, ironically, we absorb very little of it directly. However, these bacteria can secrete folate metabolites that feed back into systemic folate pools indirectly or modulate local immune responses in the gut lining. This is key because folate is not just about preventing neural tube defects in pregnancy. It's deeply involved in methylation, homocysteine clearance, and neurotransmitter synthesis. If your gut flora is deficient in folate-producing species, you may end up with systemic low-grade inflammation, poor detoxification, and impaired cognitive function, even if your diet looks fine on paper. And it's not just about making vitamins. It's also about using them efficiently. The microbiome helps regulate the expression of transporters and enzymes involved in B vitamin absorption, and can also influence how those vitamins are distributed throughout the body. A well-balanced gut promotes tight epithelial junctions and reduces gut permeability, meaning the vitamins you consume are more likely to end up in your bloodstream rather than fueling inflammation via leaky gut pathways. In contrast, when the microbiome is imbalanced, such as from a high-sugar, low-fiber diet or chronic antibiotic use, absorption of niacin and folate can falter, and inflammatory cytokines may interfere with their function at the cellular level. Where this becomes especially critical is in the brain. Both niacin and folate are essential for neurological health, and disruptions in their metabolism have been linked to everything from depression and fatigue to neurodegeneration and cognitive decline. Folate, for instance, plays a key role in synthesizing dopamine, serotonin, and norepinephrine. A lack of microbial folate production, or poor absorption due to gut inflammation, can lower these neurotransmitters and increase the risk of mood disorders. Niacin, on the other hand, helps maintain NAD levels in neurons, supporting energy production and protecting against oxidative damage. Some researchers have even hypothesized that microbiome-driven deficiencies in niacin could contribute to neuroinflammatory disorders or accelerate age-related brain aging. What's especially ironic is that many people try to fix these problems with supplements, without realizing that their microbiome might be blocking the door. High-dose niacin or folic acid supplementation in someone with poor microbial diversity could lead to unmetabolized forms of the vitamins circulating in the blood, which have been associated with potential risks like immune dysfunction and cancer promotion. A better strategy? Feed the microbes that make and modulate these nutrients: fiber, prebiotics, fermented foods, polyphenol, and reduce the inflammatory insults that derail their function. Because in the end, your gut bugs are not passive bystanders in vitamin metabolism. They are engineers, couriers, gatekeepers, and occasionally saboteurs. So when it comes to vitamin B health, you're not just what you eat, you're what your microbes do with what you eat. A robust, balanced microbiome may be the most important supplement you never swallow.